Hello children, I am Sonali Kelkar from City International School, and today we are going to do the chapter first from physics, that is light reflection and refraction. So in our last session what we did 6 images of concave mirror where the object is placed at different position, right? And we did the rules of the formation of image also. I'll start with the recap of the rules, and we will go through all images, and then I'm going to take up the next topic, right? So let's have a look of the rules, because these rules are very important when you are drawing ray diagrams. See, ray diagrams are very important. From ray diagrams you will know about the sign conventions, and sign convention will help you to solve the numericals, right? So these all are interlinked. So to have a very clear picture of the rules, ray diagrams, sign conventions, magnification and numericals, these are the basic things that you should know. Okay, so I am repeating this again. So let's start with the rule. Rule first says that when a ray is parallel to the principal axis, this is what is our principal axis, right? This is a concave mirror. Now concave mirror, as I told you, it's a cave, right? Also, and the inner side of the concave mirror, right? This is a reflecting side, the cave side. The inner side is a reflecting side. So inner side is a reflecting side, right? And the other side you have, that is the polished one where you have to put lines, right? So if an object is placed, now the object is placed in front of the mirror. This is the front part of the mirror, and the object is placed in front of the mirror, right? Now this line which is passing through the center of the circle, let's take that this is a sphere, right? All the spherical mirrors, they are the part of a hollow sphere, we know that, right? And if I see this line, okay, this is nothing but just like a diameter of a circle, right? That whole thing, that line is known as principal axis, right? And the center, okay, center will be the radius. Here let's take, okay, let it be this, be the center, right? So center is nothing but the radius of that circle. F is just half of C and P. This is a pole, right? Pole is it is a midpoint of the spherical mirror, okay? And what is F? F is almost a center of curvature and pole, okay? It is half of the radius, right? So C is nothing but the center, right, which we can relate with the radius, and F is focus, which is half of the radius, or we can say half of the distance between center of curvature and pole, right? Fine. Now coming to the rule, right? And the distance between F and P is small f, which is known as focal length. Children, you should know all the terms. Clear? Right. Now here coming to the rules of the concave mirror, right? Now here let's take a object. When a light, the first rule say, okay, when a incident ray is parallel to the principal of axis. Let me rub this. When the incident ray is parallel to the principal axis, after reflection it passes through the focus. Let me draw. This is our concave mirror, right? This is our focus. This is center of curvature. This is P. Now let's take an object over here. Fine. Okay. This is the top part or the head part of the object. This is the bottom part of the object. Fine. We are going to take only 2 rays. We are going to take only 2 rays to form all these ray diagram. These are the standard rays, right? So when a ray parallel to, see, this is my incident ray and this is parallel to the principal axis. Okay, after reflecting back, it passes through the focus. This is my first rule. Same in case of convex mirror, right? This is incident ray, right? This is incident ray. Fine. After reflecting back, this ray is reflecting, because in case of This is a shining surface of a convex mirror. The bulge part of the convex mirror, the bulge part, okay, the bulge part of the convex mirror is a reflecting surface, right? The other part should be the polished one. Fine. Now this is a this is a convex mirror, right? And a ray, this ray is parallel to the principle of axis, right? After reflecting back, this ray has reflected, right? This ray has reflected. We have to produce this ray back because in convex mirror, rays are diverging. So they are not going to meet. Diverged rays will never meet, right? Only the converged ray will meet. In reality, converged ray will meet. Diverged ray will not meet in reality. As you know, the diverging rays, how can they meet, right? So we need to produce that ray backward and then the image will be formed at the back side, right? So we need to produce the ray, and when we produce the ray, this ray, because it was initially parallel to the principal axis, when produced back, it has to go through the focus. Clear? So this was the rule 1. The rule 2 says it is just opposite of the rule 1. The rule 2 says that if a ray, now this is a ray, it is passing through the focus. If a ray is passing through the focus, after reflecting back, it will be parallel to the principle of axis, right? Same in case of convex mirror, right? So convex mirror, this is my reflecting surface, right? This ray is passing through the focus. This ray is passing through the focus, right? This ray is passing through the focus. So after reflecting back, I have put the reflected rays with the red marker, right? So after reflecting back, it is parallel to the principle of axis, right? So these are the 2 rules. Let's take the 3rd and 4th rule. So the 3rd rule says that this is my concave mirror, this is focus, this is curvature, right? Okay, if a ray passing through the center of curvature, this is C is the center of curvature. So if a ray is passing through the center of curvature, let's take it, this is an incident ray because it is passing. After reflected back from the mirror, it will take the same path. It will take the same path. This is what is my concave mirror. The cave part is a reflecting part, right? So if a ray passing through the center of curvature, after reflecting from the mirror, it will take the same path. Clear, children? Right? And then we will do the same diagram with convex mirror, right? This is convex mirror, right? This is my F. This is my center of curvature. If a ray is passing through the center of curvature, right? This is my incident ray, right? Passing through the center of curvature. So after reflecting back, it will take the same path. Clear, children? So after reflecting back, it is going to reflect from the surface. It won't reflect from here. This is where I have produced that ray. There. This is the reflecting part. This is the part of the sphere. So it is going to reflect from this part. Clear? So please don't show this reflected arrow over here. You have to show it here, right? So this is what regarding the 3rd rule. Coming to the 4th rule, which is very easy rule, right? And this rule says that here is my pole, right? Here is focus, center of curvature. A ray which is incident to the pole. A ray which is incident to the pole. Okay. After reflection will be reflected back obliquely. That means this ray is making a certain angle at P. So after reflecting back, it will make the same angle from the P. So oblique ray is forming, right? So this and this angle of incidence, angle of reflection will be same. Clear? This is in case of concave mirror. Let's see in convex mirror, right? Fine, this is pole. So when ray is coming, making a certain angle at P, it will be reflected back in the same manner. Because this is the surface, so ray has to reflect back from the surface. So this is all about the rules, okay, while making ray diagrams. So this is all about recap, and the next point in recap is the images which we have made, which are formed at the different position when the object was placed at the different position in case of concave mirror, right? So there are 6 images which are there in case of concave mirror. Let's revise it first, right? So if you remember, what was the first case? Concave mirror. Okay, fine. So in the first case, the object was at the infinity. The object was at infinity. When the object was at infinity, you can just show the 2 parallel rays. Clear? You can show the 2 parallel rays. We need to take 2 rays, right? So the cave part is a reflected part. You have to shadow the other part. This is my first ray, right? Coming from an object which is at infinity, right? And this is the second ray, coming from the object which is at infinity. Remember, we need to take 2 rays, right? These are the incident ray because they are coming, so they are incident ray. So after reflection, what about this? Focus, center of curvature, right? After reflection, what happened? When the rays are parallel to the principal axis, after reflection, it passes through the focus, right? So here, after the reflection, it is passing through the focus. Clear? You have to mark arrows. Okay, I have already given the instruction in my last session. Now, the important thing, the position. This is the position. I'm just writing position of image. Image position and nature. Nature of image, right? I have used a short form. A position of image is at focus. At focus, you can write at focus. Focus. Position of image is at focus, and what about the nature of the image? See, here the rays are reflecting back and they are really meeting. They are meeting really, that means they are forming a real image. And always remember that real image are always inverted. Real image are always inverted. Okay, so real and inverted. Real and inverted. Clear? And what about the size? Size is highly diminished. HD is short form, right? But don't write HD in exam. Highly diminished. Highly diminished. Okay. So this is all about the first. Focus. Curvature. Again. So my object is beyond C now. The object is beyond C, and I'll take a ray parallel to the principal axis here, which after reflection, which will pass through the focus. Fine. And then the second ray will pass through the focus. Here, this is focus. And after reflection, it will be parallel to the principal axis. So where these in refracted ray, this was an incident ray, okay, so this was a refracted ray. So wherever this refracted ray are meeting here, the object is, or the image is formed. Clear, children? I'll just make it, this is the refracted ray, right? So this is the refracted ray. The red one is a refracted ray from here, and this is also a refracted ray, right? So they are meeting over a point, and an image is formed over here. As you can see, the image formed between C and F. Let's see the position of the image between C and F. And what about the nature of the image? Nature says that because these rays are, okay, they are converging, they are meeting in reality, so they are real image is formed, real image, real, and how about inverted? Real and inverted images form. And what about the size of the image? It is diminished. It is smaller than the size of an object. So you can write diminish. So the third ray diagram of the concave mirror. Let's bring the object near to the mirror. Fine. So this is F, this is C. Okay, in the second case, the object was beyond C. Now let's bring the object at C, at center of curvature, right? When the object is at center of curvature, I'm making a rough diagram, children, here, just to make you understand, right? We have already done this. So let's take the first ray, which is parallel to the principal axis. After reflection, passes through focus, right? The next ray will go from the focus. After reflection will, okay, after reflection will be parallel to the principal of axis. So let's take over here, object is, the image is forming. So image will form, one thing you need to understand, image will form only when the reflected rays are meeting. Incidence rays doesn't play any role in the formation of images, right? Okay, so when the reflected ray, this is my reflected ray, right? And this is also reflected ray. When these two reflected ray, when they meet, then the image will be formed. Now if you see the position of the image, that you have to write at C, right? So position is at C. Now what about the nature? The same size. Okay, size of the object and the size of the image is same. So you can write same as that of object. The image is same as that of object, right? And yes, it's real and inverted. R and I, right? Real and inverted. Clear? Now coming to the fourth diagram. So fourth diagram, now what to do in fourth diagram? Already we have placed object at C. Now the object will come again near or towards the mirror, right? Now here F, C, okay. So let's bring object near to mirror. So let me place the object between C and F, between center of curvature and focus, right? Now first ray will go parallel to the principal axis. After reflection, okay, after reflection it will pass to the focus, right? Now what about the second ray? Second ray will be passing through focus, right? And after reflection it will, after reflection it will be going parallel to the principal of axis. Now if you see, the image is formed here. So this is the reflected ray. This is also a reflected ray. Yeah, this is also a reflected ray. So incident ray and incident ray. Right. Okay. Now if you see position of the image, now the position of the image is beyond C, right? It is beyond C, right? Fine. And what about the image? Image is enlarged, and it is enlarged, real and inverted. Okay, enlarged, real and inverted, right? So let's do the fifth ray diagram. The fifth ray diagram in which now we are going to place object at focus, because we have placed at C, then between C and F now focus. Here is our focus, center of curvature. Now object is at focus. This diagram you need to be very careful, children, right? Because there is a little change in this diagram. So when the incident ray is parallel to the principal axis, after reflection it will pass through the focus. Done. Okay. What about the other ray? Now already the ray has passed through the focus. The second ray, okay, the second ray will pass through the center of curvature. The second ray will pass through the center of curvature, and we know that when a ray passes through the center of curvature, after reflection it takes the same path, it reverts back. Okay, so if you see, these rays are almost, they are parallel to each other, but we assume that somewhere in infinity they are going to meet. Okay, and the position of the image will be at infinity, right? It will be at infinity and the nature will be highly enlarged. Real, yes, because they will going to somewhere going to meet. Okay, so that's, they are going to meet really. So real then inverted, real and inverted goes hand in hand, and highly magnified. Okay, this is all about the fifth one, and let's do the sixth one. The sixth one, in case now we have already placed at focus object. Now in the sixth case we are going to place object between focus and pole, right? So in the sixth ray diagram of concave mirror, we are going to place object between focus and pole, right? Okay, center of curvature, focus and pole. You are seeing the object is coming towards the mirror, and the images are going on away from the mirror, right? In the last 5 diagrams, here the story will be different, right? So I'll just extend this line, principle of axis, right? Now let's place an object between focus and the pole here, and now the ray which is parallel to the principle of axis, right? After reflecting back, it will pass through the focus. This is passing through the focus, right? So this is what is our reflected ray. So this is reflected ray. Children, you have to produce reflected ray back. You don't produce incident ray back, please. Okay, remember, this is the reflected ray and I am going to produce it back, right? And a ray which is passing through the center of curvature, right? I'll take a ray passing through the center of curvature. Sorry, passing through, this ray is passing through the center of curvature. Other incident ray will be revert back in the same direction, right? Fine. Rule number 3. It will, and now this reflected image you have to produce backward. Okay, you have to produce backward. So the image will form like this. Now because these rays are not meeting in reality, they are not meeting. So that is why the image formed in the 6th case of concave mirror, you can see it is an erect image, right? Position you can write behind the mirror, right? Behind the mirror, how is the image? It is virtual. It is virtual and erect. Why virtual? Because it seems that these rays are meeting at the back. They are not meeting exactly in reality, right? So it is virtual. With virtual, which word goes? Erect. Virtual and erect goes hand in hand, right? So this is what about the nature of an image. And how is the image? Image is enlarged as compared to the object. So that you have to write enlarged. So this is all about the concave mirror, children. Okay. So the next we are going to do the sign so we have to do the convex mirror. Yeah. Now we did about the images formed by the concave mirror. Now we have to do the images formed by convex mirror. Okay. There are only two images regarding the convex mirror. Clear? Only two ray diagrams are there in your syllabus regarding convex mirror. Clear? So this is what is my convex mirror. The bulged part is a reflected part and the inner part is the polished one. So you have to mark like this, right? Now we have to take the first case of concave mirror where we have placed an object. The first ray diagram in concave mirror, we have placed the object in infinity or at infinity, right? So the same thing we are going to do here. Let's mark focus, center of curvature. Here it is a pole, right? Now object is at infinity and we know that when the object is at infinity, what you have to take? You have to take two parallel rays, right? So two rays parallel to the principal axis. Now according to the rule, when the two rays are parallel to the principal axis, after reflecting back, okay, they will be passing through the focus. Now let me reflect this image once, because this is a mirror, so when it will bounce with the mirror, definitely you're going to reflect back. So this is what is a reflected ray of this, and this ray will also get reflect, right? So after reflection, where they are supposed to meet? They are supposed to meet at focus. So let me extend or produce this ray backward, right? Yes. Over here the image is formed at focus. Now you can see the image is point size image, but don't write point size image. Okay, so let's write about the position and the nature of an image. Position is at focus. So you can write at focus. Okay. Position, nature, highly diminished. Highly diminished. Okay. Highly diminished. Clear? Because the rays are not meeting. This is a convex mirror. In convex mirror, rays are diverging rays, right? They are not going to meet anywhere. So we just assume that they are meeting. So they are not meeting actually. So the image form will be virtual and erect. So, okay. So virtual and erect. Virtual and erect, these two words, okay, they go hand in hand. So virtual and erect. This is all about the first ray diagram of convex mirror. Now let's do the second ray diagram of convex mirror, right? The second ray diagram, let's start with the second ray diagram of convex mirror. Okay, now this is the bulge part, this is the principal axis, right? Initially in the first we did that we placed the object at infinity, right? Now you have to place the object anywhere on the principal axis, right? This is P. This is my focus and this is C, right? Okay. P and F, this length is called focal length, right? Distance between pole and F is focal length. If it is 4, then the distance what you have to take between P and C should be 8. Okay. So this and this distance should be same. Okay. Right. Now let's bring object over here anywhere on the principal axis, right? And what happened? Okay, now the first ray will be parallel. The first ray is parallel to the principal axis. It will reflect back. This is incident ray, this is refracted ray. Okay, and it should, where should it pass? It should pass through the focus. This ray is passing through the focus. After reflection, it is passing through the focus. Fine. And what about the second ray? Let's take the second ray passing through the center of curvature. This ray is passing through the center of curvature. When a ray passes through the center of curvature, it is reflected back in the same path, right? So this is, I'll just because we are assuming that this ray is passing through the center of curvature. So where are they meeting? They are meeting over here, right? So what about the position of an image? Between P and F, anywhere between P and F. So position is between P, that is pole, and focus, right? Between pole and focus. Fine. And what about the nature of the image? Nature of the image is erect and image is also diminished and virtual. It is virtual and erect and diminished. Right? So this is all about the images on concave and convex mirror. Children, if you have noticed very carefully, the nature of the image which we have discussed in concave mirror, we couldn't able to find out an image or we cannot able to produce an image which is diminished and which is erect. Okay, in the last case of concave mirror, the image was enlarged and it was virtual and enlarged, right? But we couldn't able to find out the virtual and diminished image. So that was possible only in the case of convex mirror. Now what is the use of convex mirror? The use of convex mirror we use as a rear mirror in vehicles, so that you can have a broader look of the traffic, right? So and the images are also erect, they are small, they are erect, and you can see from your vehicle, right? In vehicle you can see what all vehicles are coming from the back, right? So it gives a broader view. Then in shops and even in parkings, you must have seen mirrors, big image mirrors, right? So in case of in shops, they put these mirrors so that they can have a complete look of that particular shop, right? And even in parking, so that you come to know that which all vehicles are coming inside while you are going out from the parking, right? So these are the uses of convex mirror. So this is where I am going to end this session. Practice all the ray diagrams, children, and practice what I have been taught today. On Thursday, I'll be taking the next topic of the mirror. Okay, so we will be doing 2 consecutive physics period in this week, so that we can able to complete major part of the portion. Thank you so much.